Hello and welcome to Technical Utkranti, and today we are going to see the last question on binary search, which is aggressive neighbors. So if neighbors are aggressive, they need to be placed in a way such that the distance between any two of them is maximum, right? So let's see how are we going to solve this question. And before that, let's have a look at the thought for the day. These lines basically means that we should not be having affinity towards a person or enmity towards someone. So these are the questions that we have done in binary search, and our next video would be on heap data structure. So let's move on and understand the question. So you are having C neighbors, C number of neighbors, and there are n houses, and each house is numbered like 1, 2, 3. Okay, you need to place the neighbors in C neighbors in these houses such that the distribution maximizes the minimum distance between any two neighbors. So, for example, there are six houses, one, two, three, four, six, numbered like, sorry, five houses numbered like one, two, three, four, six, and you have to place three neighbors in order to maximize the minimum distance between any two neighbors. Then a distribution would be 1, 3, and 6, and the minimum distance is 2. So I hope you understood the question. Let's go and understand now how are we going to solve it, and that we can easily understand with the code itself. All right. So we start from here. What we do is we first of all sort all the houses. So this represents position of houses. All right. And then we apply binary search. So what is the minimum distance that can be there between neighbors? So if all of them are placed in the same house, let's say, then we have zero distance. And if the two neighbors are placed at the maximum house number distance, then I'll basically subtract the maximum from minimum. That's why I sorted it and put it in high. So we have low and high, and then we go on to do binary search until low is less than equal to high. Then I calculate mid, and I see that with this particular value of distance, can I do a distribution? All right. So I basically what I do is I I assign the first position to the first house, make the count equal to 1, and then I iterate on the rest of the house's position. And then I see that if the whatever is the next position at mid distance apart. So comp is basically mid. So once I found that position from which the previous house distance is at least at a distance of comp or mid, then I increase the count and make uh, my prep value is equal to the current position. And I keep on incrementing the count. So before this n gets exhausted, if my count is equal to c, or the number of neighbors. So I have placed C number of neighbors. Then I'll say that, okay, this configuration is possible. So with this value of mid, I am able to place the neighbors. I am able to place C neighbors, and I'll return true. Otherwise, if the n exhausts and the count does not reach to C, then I'll return false. So if the distribution is possible with this value of mid, then I can say that I can increase the distance between the neighbors. I can try increasing the distance between the neighbors, right? So I'll give low equal to mid plus 1. Here I have to maximize the distance. So if I get a solution at this particular distance, then I'll go on to increase the distance and see if that is also possible, right? So that happens by making low equal to mid plus 1. If that is not possible, then I'll make high equals to mid minus 1. I'll try with a smaller value. All right. So This will go on until low is less than equal to high, and we'll finally return the result value. All right. So let's run and see if our code is acceptable. Yes, it is. So I hope you understood the question, the approach, and the Python code. If you did, please give it a thumbs up and subscribe to my channel. Thank you. Bye bye.